भाई कैसे हो? तो आज है स्टोन गेम 4। कल भी स्टोन गेम ही था ना। सो लेट्स सोल्व दिस क्वेश्चन. वी आर गोइंग टू फॉलो द सेम steps that we did yesterday. First step is observe. Second step is try to get the winning state equation, or you can say winning state function. How can we win basically? After that, these questions are very simple. Okay, so let's read today's question. Alice and Bob turns playing a game. Okay, Alice starts first. Okay, initially there are n stones in a pile. Okay, there are n stones basically. I think earlier there used to be an array in that there are some x1, x2, but now there are only n states. On each player's turn, that player makes a move consisting of removing any non-zero square number of stones. So they can only remove square, like in the chunk of squares basically. Either they can remove one, they can remove four, they can remove nine, and so on. Only these they can remove. Okay, if a player cannot make a move, he or she loses the game. Okay, so today it's not about how much they can collect. It's all about if whether they can make a move or not. Let's say it's simple, right? As if we have some n equals to 4, right? Then Alice can pick all 4, right? Then he can win. If n equals to 2, Alice can pick 1. Now Bob can also pick 1, right? So Alice loses. See, Alice cannot pick 4 because there is no 4. Okay. And what are the constraints? Constraints are n into 1 e raised to power 5. Okay. So, and see total squares, right? I into I is less than what? 1 e raised to power 5. If we check for each squares, then it's basically root n, right? So n root n, if we do a recursion, right? Recursion with memo. I think this is just n root n will pass, it will not give us TLE. Okay, so let's do a dry run. Okay, now dry run will do for n equals to 7. We have different equivalent. This is Alice, this is Bo, this is Alice, this is Bo. Now from n equals to 7, we are going to start with position equals to 0. Okay, now initial, what choices Alice have? Alice can either pick a 1, okay, either 1 square. Alice can do 4, that is 2 square. Alice can pick just nothing else, right? Okay, so see, if he picks 9, he eventually loses the game, right? If he picks 9, Alice only loses the game. Okay, so next turn will come Bob, right? Now we have position equals to 1 here, position equals to 4 here. Right? Now, if it's 1, see, Alice again, right? Bob can take 1, then position becomes 2. Bob can take 4, position becomes 5. Can he take more than 4? No. Similarly, here, right? Bob can take again 1, again 4, right? If Bob takes 1, then position becomes 5. And here it becomes position becomes 8. So this is losing, right? So he will not pick this, he will go via this branch only. Now, again at this step, right? Alice pick 1, Bob comes at 3, Alice picks 4, Bob comes at what, right? 6. Now, in this one, Alice picks 1, for Bob it becomes 6. Alice picks 4, he loses, right? Right, this is losing state. Again, this is right, this one is same as this one, right? And these, okay, and this one, same as this one. So these we will avoid via memoization. Okay, these we have to avoid via memoization. So I think this is not clear. So that's why memoization is necessary. Otherwise, the time complexity will become of n cross root n for the basic recursion. Now, the next part is okay. Let's now we are left with position 3 and position 6 basically. Everything else comes to a losing, right? This again become right. Either pick 1, either pick 4. If it picks 1, right, both picks 1. So Alice left with position what? 4. Alice, right? Alice is at position 7 now. Can Alice pick anything here now? So this is also losing, right? Now, if this is 6, he can pick 1, right? Position becomes 7. Now these two are same. These are again losing state. So they will not pick this one. Okay. So now we are left with only one state, that is position 4. Have you already encountered position 4 before? Yeah. So we have position 4 already. So all the states are losing states basically. So who wins? Bob wins. Now in this recursion, what we have seen, right? Our recursion depends upon what? Now let's write the recursion. Okay. Now recursion depends upon what, right? Recursion only depends at every position. We tell if the next player, right? See, if the next player, let's say I'm at Alice, right? I will tell if for this path, can Bob win, right? Recursion is what? For a choice, right? For a square, right? For a square chunk choice, right? For a square chunk choice. Can next player win, right? We are left with this question now. Okay. So this is simple, right? Recursion is now, I'll just say, can win, right? We'll pass it at position basically. Now, see, if, right, if this position greater than equals to what? N. See, we simply have no choice, right? The current player have nothing to pick, right? current player, right? Cannot pick anything. This is right. Okay. Now, if this is right, then we check for each word. We check for each squares, right? I1, I cross I less than equals to what? Whatever is your maximum. I plus plus I. Now for each position, what do we do? So we check the next chunk size, right? After picking the next position becomes what? Position plus I into I. See. Now if this next, right? If it's greater than n, just break, right? Because this is a losing state, right? If n greater than n. And any part that is above this one is also not possible. So now we'll check, right? If the next player can win. If we pass this position, can the next player win? If this is true, we return true. See, if next player win, see next win, that means I lose, right? Therefore, next, if the next player lose, right, who wins? Me. So this is, we check the negation, right? So this is the BFS, and in the end, just return. So this is the DFS now, right? The time complexity is of n cross root n. Why? Because you see, one state we keep encountering again and again, right? Okay, so then how we are going to memorize it? Since position, this canWin only depends upon position, right? So we'll declare a simple, right? You declare, right, a memoization of n. You do check here, right? If memoization of n not equals to -1, you simply retain that state, right? Otherwise, here, right? Here you can put, right, memoization of what? Current position equals to what? True. And here what you can put. Since there is no winning state for this current position, this will be 0. So that's it. That's it. So this is the simple question. Then the time complexity will become of n root n. Why? Because we only encountered each state one. See, each state once, right? Square loop over each state. So that's why. And why do we encounter each state one? For, let's say I equals to 1, right? If it's 1, we do 1, 2, 3, 4, 5, 6, 7, 8, and so on. That's why. Okay, that's it. Thank you. We'll see the code part. It's very simple. It hardly take 2 minutes. Okay, so see the code part. Code part was simple, right? We first have to write a recursion that was only depend upon position, and we just simply return canWin, right? I think we can make the same function change, right? If n, right? Mm, if it's less than 0, right? If n less than 0, we return false, right? Because there is no position now. So then the next one was for anti I equals to 1, I, right? I cross I. It should be less than what? 1 if I less than equals to 1 if I plus plus, right? Anti next equals to what, right? N minus I into I if can win, right? Next, we simply return true. And in the end, if nothing can win, we return false. And we need to break this one, right? If this next, right? Next less than 0, break. Okay. I mean, it looks simple. I just reversed it basically. Okay, so I think should work. Now we can memorize it, right? We need a vector, we need a anti, right? We need a vector anti memoization, this, right? Where should we use the vector now in it? Whenever they instantiate the class, can we do it once, right? Because for all state, it will be same, I think. So solution memo equals to what will be the size of our memo, right? Vector int, right? This is maximum 1e5, right? 1e5 plus 1 comma minus 1 with 4. If memo, right? If memo of what? If memo of 1 not equals to -1, we return memo of n basically, right? Greater than 0, right? So it's either 0 or 1, right? So we can simply do this one, right? So if it's true, we can memorize here, right? Memorize of n equals to 1, and we can do memo of, right? Memo of n equals to false. Now let's see. So we instantiates when it becomes class solution, right? Implicit declared private here. Uh, don't know if it's public or not. Calling a private constructor of class solution. So this should be okay, right? Because private constructors cannot be called outside the class, but when we instantiate it, it's getting called outside the class. So let's submit. See, right? It works. So I know this is getting a little bit confusing since it's this memo, right? This can be a global for this particular class. Why? Since n, right? N does not depend upon each test case. See, if you will give me n equals to 7 in any test case, right, it will be only, you will always get false for it, right? So that's why you can make it global. And if you don't want this approach, we can just simply let's do some other approach, right? Let's simply do return canWin, right? We can canWin, right? We pass the position 0. We need the memoization here, right? Memoization equals to what, right? Vector int n, right? N plus 1, let's say. We need this minus 1. We need this vector here, right? Vector int memo, we need then boolean canWin, right? We need int position. We need the similar approach, right? So if position greater than equals to, right? Let me say int n, and we can do this dot n equals to n. So if position, right, return false, there is nothing to pick. Otherwise, what, I equals to 1, I cross, right? I cross I less than equals to what? 5, I plus plus, what do we do? And the next position is what, right? Next equals to what? Position plus I into I, right? So if we do, we simply check, right, if next player can win with this position. If he can win, we do memo of next, right? Memo of position. Memo of position equals to 1, return what? Return memo of position equals to 1, we can do. We can do return memo of, right, memoization of position equals to 0. False we can do. We can check here, right, if next greater than n. If next greater than n, we return false. We break basically. Just break. Looks good. It's simple question. The only part that you need to understand is how to solve, right? Number, reference type, solution quantity. Quantity did you mean to use this? Okay. First, always try to observe the what mathematical equation you need. Then there are like 1,000 ways to code, right? Coding is, see, code is easy. The thing that is difficult is understanding the problem. So now we are getting TLE. Why? Because we haven't checked here, right? If memo of position not equals to minus 1, we return just simply the. What is the point of updating if we are not using it, right? So yeah. Hmm. So you see, this is easy, right? Thank you. Oh, let's analyze the time complexity as well. I think I left one for the day. And you always try to read other people's solution. That will be the best thing that you will do. This, I guarantee you. When you start reading other people's solution, you will know what different kind of approaches is there. Say, I did not know that I can globally do for solution and then use it for everywhere. I just did it right now. It come to my mind. I did it. So if you will go, you will check and read other people's solution. That's really important, and it will benefit you a lot. Thank you.